Hi everyone! In this video, we are going to be talking about the LOS, explain how the price of a bond changes if the discount rate changes, and the bond approaches its maturity date. As a prerequisite, you would need to know how to calculate the price of a bond, especially bond valuation using the TVM functions on your calculator. If any company, for example, XYZ Corporation, issues a bond with a face value of $100, coupon rate of 10%, tenure equals to 10 years, and an annual frequency, the cash flows would look like this. The value of the bond would be given by this formula, where N is the number of years and I is the market interest rate, or the YTM. Alternatively, you can value the bonds using the TVM functions. N is equal to 10, the future value is equal to 100, the PMT, which is basically the coupon, is equal to 10, which is basically 10% of 100. And I is equal to the market rate. Now, what you would be doing with your calculator is computing the present value. Let's try to understand how the value of this bond would change at different interest rates. The same bond is shown in dark blue. The total dollar value of these payments would be 10 years times $10 for each coupon, plus $100 face value, which is basically equal to $200. If the market rate is 5%, the present value of each of the dark blue cash flows would reduce to the gray bar. If you add up all of the gray bars, you would find the value of the bond at 5% discount rate would work out to be $139. As you can see, when you discount the same dark blue cash flows at a higher interest rate, such as 15%, its present value falls to an even larger extent, as you can see in light blue. The sum of all these light blue cash flows works out to be $75. The main takeaway is the higher the interest rate, the cheaper the bond. This is basically the inverse relationship between market yields and bond prices. In this slide, we talk about three interest rates: 5%, 15%, and 0%. Now let's take a look at how prices change at other discount rates. If we plot a graph with the discount rate on the x-axis and the price on y-axis, we get a downward sloping curve. As you increase this discount rate, its price decreases. Also note that when the coupon is equal to the discount rate, in this case 10%, the price of a bond is equal to the face value, which is $100. Let's take a look at how the value of a bond changes with the passage of time. Let's consider the first bond described here. Here, the coupon is 5%, the tenure is 2%, its YTM is 10%, its face value is $100. You can calculate its market price by entering the following into your calculator. The PMT is basically the coupon, which is equal to $5, which is basically 5% times $100. N is the tenure, which is equal to 2. The interest per year is equal to 10. The future value is equal to 100. Now, compute the present value, which is equal to $91.32. Since the present value is less than the face value, this bond is trading at discount. After a year, if the interest rates are still the same, to find the value of the bond, all you need to do is change n is equal to 2 to n is equal to 1, as there is 1 year left to maturity. Now, by computing the present value again, you see that the value of the bond is $95.45. And to get the present value at maturity, you just need to make n equals to 0. And when you compute the present value, you get $100. Please note that your calculator's memory stores the values of the TVM functions, even if you switch off the calculator. If I plot a graph with the passage of time on the x-axis and the value of the bond on y-axis, I get a curve that looks like this. As you can see, the discount amount decreases over time. In other words, the discount amortizes over time till the bond trades at par at maturity. Now let's take a look at the second bond. This is similar to the first bond, except in this case, the coupon is 10% and the YTM is 5%. This means that the coupon is higher than the discount rate. That means the bond is trading at a premium. So when you enter all this on your calculator, your PMT would equal to 10. Your interest per year is equal to 5. Your face value again is 100. N is equal to 2. And you'd be computing your present value, which would work out to be $109.30. A year down the line, when you change n to 1 and again recalculate these values, you get a present value that would equal to $104.76. And at maturity, when n is equal to 0, the present value would equal to $100. Similarly, when we plot this on a graph, we can see that the premium decreases over time, or the premium amortizes till maturity. This concept is called pull to par. What pull to par basically means is that whether a bond is trading at premium or at a discount, as it approaches maturity, it converges to the par value. So whether a bond is trading at a premium, it will converge to par value, or a bond is trading at a discount, it would converge to par over time. Let's look at a question. It's given in the question that a bond is trading at $970. Now, it's not given in the question, but you need to take the par value is equal to $1,000. So basically, this bond is trading at discount. If we plot a graph using the concept of pull to par, we know the price of the bond would follow this path. Now A increases. As per the graph, the price increases. But before we finalize this answer, let's take a look and see why the others are wrong. B decreases. This certainly does not decrease. However, a bond trading at a premium would decrease. now remain the same. Now this is wrong because a bond trading at par wouldn't change over time. Now we've come to an end of another LOS. Thank you for tuning in.